आ रहा है ना?
हो रहा है?
हाँ हो रहा है। हाँ हो रहा है।
जूम कम कर सकते हो बस
ठीक ठाक नहीं हो रहा है।
Okay, so far we haven't discussed SAP 2000, right? This is also similar to Etabs, the product of same company, CSI, okay, Computer System Structures. The difference is Etabs is basically used for analysis and design of buildings. So whatever customized options you need for building design, that will be available in Etabs. Okay, but SAP is a general purpose software, so you can design buildings or any kind of structure. So the customization tools will be less compared to Etabs. Okay, but it has means in certain aspects it will have advantage. Like if you want to simulate customized member behavior, so there SAP 2000 is better compared to Etabs. Okay, we'll see what is the difference with respect to a section. You know, if you have a section given and the reinforcements are specified, so how to calculate the moment curvature of that section, you are already studying that. Okay, and with respect to confined or unconfined. Okay, now we'll see in software and what is the difference between Etabs and SAP. Okay, first we'll try in SAP, after that we'll go to Etabs. Yes? Oh, sorry. So interface is also it's similar to Etabs. Okay, this is SAP 2000 actually, but this interface is familiar. And
Sir, are you recording?
Yes.
Are you recording, sir?
Yeah. So let it be by default, whatever is given, because I don't need this one, I need just a simple section. Now first thing you know, you have to go to define materials. Okay, same as it is. So let us use M30. FA5 and FA4. Now you have to define the section. So the section designer option is basically useful when you have like customized shape. Normally we use either circular or rectangle, but if you that is either RCC or steel, you have basically two general options. But sometimes what happens, we use composite sections. Okay, so those composite sections are not available in Etabs or SAP directly, but there is a option given section designer where you can design the member then use it. Okay, so for that purpose we can use this section designer option. admin property, then you have to click on this other option and you have to click on this section design. Let's give RC form and base material you have to choose concrete. Means I am assuming I am going to create a RC section. So it will have concrete and steel and the base material will be concrete. Now suppose you want to create a steel section, so your base material will be steel. Okay. And take a shape, let us choose rectangular 300 by 600. Okay. So here you can see you have some options available. And again, if you have like random shape, it is not either circular or rectangular. So that time you can use polygon option. You can draw the line. So you can create a shape. But now since our section is going to be rectangular, so it's easy, you can choose this rectangular option. But if you want a polygon, here this option, okay, you can click on this option, then you can create any type of shape, whatever you want. Clear? See, now pi difference has given me some dimension. This now I have to customize. So what you can do, you can just put your cursor anywhere in this section, then right click. Okay. Now it is 500 by 500 section. Let us make it 300 by 600, 0.3 by 0.6. Then see, here it is saying that core dimension is program determined. Means I have given the overall dimension. Then based on my cover thickness and reinforcement details, it will calculate the dimension of core. Means the confined area. Okay. So either you can allow the software to do it automatically, or you can do it yourself. Okay. Then reinforcing by default it is chosen as no, and create reinforcement details now. And see here, the concrete model is vendor unconfined. So now this is saying your model is unconfined. If you want the confined section, you just click on confined. And here you have to give some details. See, epsilon CU limit. Today you have calculated this 0.004 plus 1.4 something. So using that formula, sometimes what happens, I think this is okay. Epsilon CU. In class hardware we have to use 0.02, not 0.05. 0.05 is for steel. No, that. See, something like this, you have the stress strain curve. This is your epsilon cc. I am talking about the confined stress strain curve. Okay, and this is your epsilon cu. Fine. Now this epsilon cc you know how to calculate, and this epsilon cu also you know how to calculate. But there is a limit for this. It should be less than equal to 0.02 in case of concrete. Okay. You have studied this one, right? And in case of steel, same ultimate strain that will be limited to 0.05 when you are designing for RPM loading. Okay. But if you are not designing for RPM, that will become 0.145. So here it is given as 0.05. Let us not take to 0.02. And see, main bar it is written as number of bars is 12. Then reinforcement is the dimension is given as hash pi, because this software is used in many countries, so you will have the reference for all the different countries. This hash pi is as per US standard, so we will modify this according to Indian standard. Okay. And here let us select the material for confined means steel. Assuming we are going to use HYSD 415. Then here you can choose the diameter of your part. 6D, 8D, all these things are according to Indian standard. Okay, 6D means 6 mm diameter, 8D means 8 mm diameter, like that. Okay, now let us assume we are going to use 10 mm diameter for stirrup. Okay, and tie and cross tie. So tie and cross tie means you have peripheral stirrups, then intermediate cross tie if you need. Okay, that kind of configuration. And the longitudinal spacing is by default it is 250. Let us make it, let's say I want 150 mm spacing for stirrups. Okay, and number of ties by default it is 2. So if you have only peripheral ties, you will have only 2 legs. Okay, now suppose I want another intermediate tie also, so I have 3. So accordingly you can decide here. So let us use 3. And see, when I am changing these parameters, so just look at the curve, how it is changing. Okay. So this is how it affects. Whenever you are increasing the shear reinforcement, the strength of concrete, how it changes, you can imagine by seeing this. Okay, fine. So let us now modify the main steel. So this is concrete model. I can click on this steel model. Gone? Okay, it will come. Let me save this. Okay, so now our section is ready. Now let us modify the reinforcements. So since we are going to consider this as the RC column, so either you can consider the reinforcement throughout, or if you have any customization requirement, you can do according to that. What you have to do is just click on any of this bar if you want to modify it. Okay. Put your cursor, then right click. Okay. Now see, by default it is given as hash file. As I was saying, this is according to US standard. You click on this, then you can choose whatever you want. Let us consider 25 mm. Okay. And see, according to whatever diameter you are choosing, that area will be appearing here. And you have one more option. Either you want to go for the same size in all the corners, or you have different size requirement. Since this is corner bar, basically we have the same diameter in all the four corners. So you can click on this, then okay. Fine. Now this edge bar, again you will have, means in general both the sides will have the same diameter, but not necessarily. So whatever way you want, you can modify this. Again right click and you can choose your diameter. Okay. So like this you can customize. Now your section is ready. You have, I think this cover we can modify. This cover thickness. Okay, what you have to do, just click on any of the corner bar. I think yeah. So if you are clicking on this any of the edge bar, you have one option bar cover. Okay, so you can modify this bar cover accordingly. Your cover thickness will be changing. Okay, now I am not doing this one. Just a basic thing. If you want to change, you can change. So your section is ready now. Your
sir. So this is the clear cover.
This is no, whatever was shown inside, that is effective cover.
Effective cover.
Okay. So you can calculate effective cover whatever you need according to that you will do. See, your section is ready now. So you can just click on this option. This one. So movement curvature. If you click on this, it will give you movement curvature. Okay. And here you can apply the axial force, how much you want. According to that, this curvature diagram, means movement curvature diagram will change. Okay. Now at this moment, this diagram is for zero axial force. So it's basically representing a beam, not column. Okay. Now suppose I want 100 kN of axial force. Okay. And if you check this option, in bracket it is written as tension positive. So if you are going to apply the tension force, it will be considered as positive. So you have to apply positive, whatever numeric value you have to enter, it will be positive. Okay. But now since I am going to apply compressive force in columns, negative. So I have to assign a minus before the numeric value. Okay. Minus 100. Okay, so when you apply 100 kN, the curve little bit increased. If you have seen, I think it was not visible properly. So let us again start from 0. Just look at the curve. So initially this is the level at approximately 640 thick. Now instead of applying 100, just to maximize the variation so that you can understand, I'll apply 1000 kilonewton minus 1000. Now you can change, you can see the difference. Okay, the peak strength increased, then slope, initial stiffness if you have observed that is also increased, but the ductility reduced. Okay, so just have a look one more time. Now I am making it 100. Okay, then let's make it 0 again. So 100 and 0 only peak strength is little bit varying, but the ductility it is not visible, although it is reducing, but not significant variation, so you cannot observe it properly. So again, let's say I want to make it minus 400. Now see, after this point, okay, what happens is this change is very much exaggerated. Okay, so actually you do not need this much. For practical purpose, maybe you use only up to this much portion. Okay, this is not useful. It is showing like that, but when you take these values and plot in Excel, that time you will see and see the curvature values. Okay, normally the useful range is 0.0025 max. Okay, so 0.0025 comes somewhere here. So beyond that, that is not that much useful. Okay, so just consider this as the ultimate point. Okay, so and observe these variations with respect to the actual force. And now if I enter 400, see it is changing, it is reducing, the ductility is reducing. Okay. Now say 1000. So almost no ductility now. Okay. So this is what you have learned in class. When the axial force is acting and it's keep on increasing, so your ductility will keep on reducing, but peak strength will increase, and also the initial stiffness it will increase. Okay. Why? Because initially when axial force starts acting, means started from 0 and little bit axial force, that time what happens, it is compressing and making the member compact, so it will have higher strength. But at the same time, it is also compressing the material so that at certain level, when the force is increasing, it will reach the crushing stress. Okay, so if your axial force is so high that the stress in concrete is the limiting the exceeding the crushing stress, so obviously concrete will get crushed, right? That's why at higher axial force the ductility is not there. Okay. So you understood, right? What is moment curvature and how it varies with respect to axial forces in terms of stiffness, strength, and ductility. Okay. Now this same thing, what you can do, same example you take, solve manually and compare with the software whether you are getting the same result or not. Okay. And now we will see in Etabs how we can do the same thing. And see, this was moment curvature. Similarly, you can also get the PMM interaction. If you click on this option, it will give you PMM interaction. Okay. So it is giving in 2D plane. It means at a certain angle. If you see here, this is the angle. At this angle, it is giving you the PMM interaction. So if you change this, sorry, not this angle. Where I am getting that angle? Yeah, I think it's here. Now it is at 0 degree angle. So if you change this one, this is at 15 degree, then 30, 45, 60. You know this meaning, right? What this angle represents? Do you know? Yeah. How many of you know what this angle represents? Raise your hand. You know PMM interaction, right? This is the moment variation with respect to axial force. And I think most of you do not know this. Okay. See, normally this is the axis system you follow when you calculate the movement. One is with respect to, let's say, this is y-axis and this is x. So accordingly, you will have mx means movement about x-axis and my. Now, in terms of angle, if you want to represent this x will be 0 degree angle. Okay, so I can say 0 degree, which means mx. Similarly, if I want to represent my, how much angle I should use?
90 degree.
Okay. Now see, if I want to calculate the movement about any other axis, okay, let's say so I want to calculate movement about this and this axis. Okay, so you know how much is the angle of this with respect to horizontal. Let's say this is 45 degree. So you calculate the moment about this axis, then you say that will be m 45. Okay. So similarly, you can calculate the angle about any axis between 0 and 360. Now, why it is important is in earthquake, means during earthquake, you do not know in which direction earthquake will come. Okay. Maybe you design the building according to mx and my, and you will prove the building is safe. But what happens if earthquake is not acting in the same direction? Okay, that's why this PMM interaction is important. It will give you the capacity about all the 360 degree angles. Okay, so whatever way earthquake comes, you will have the understanding of how the building will behave with respect to that earthquake acting in a particular direction. Okay. So I think it is clear now. So like this, you can calculate moment curvature and PMM interaction, and when you are going to design the building, you will have to assign the PMM interaction. Although the software will do it automatically based on the section and then whatever is given, but you need to understand what it actually. Okay. So this was using SAT. Now, so the same thing we can do in Etabs also. The same thing here also. You have to go to this pen section, then add new property, and here see. In SAP, what we did, we clicked on this drop down and selected other option. But here you do not have to do because this option is available in this interface itself. Okay. So our height was 600, that is okay, and width, let us make it 800. See, first difference is here you do not have option to select. Sorry, I think it will come after this. No, it's not coming. In SAP, what we did, that mentor model was explicitly given so that we can choose whether to go for confined or unconfined. But now in Etabs, that is not there. Okay. So by default, what software will do, whatever definitions you are giving here, it will consider two properties. One is confined, another one is unconfined. Okay. So when you are designing the building, it will consider the unconfined properties, but when you are calculating the capacity, like you are doing the, pushover.
Yes, sir.
Okay. So in pushover, what we do, we calculate the capacity of the building, not designing. Okay. One is demand and another one is capacity. Okay. So when you are trying to calculate the capacity, software will consider the confined properties. But you do not have control here. You do not have anything so that you can choose yourself and change the parameters. Okay. Software will consider some default properties and it will consider using vendor's model. So this is the difference I was talking about with respect to the SAP software. Okay. Anyway, whatever options you have available, you can choose. And first thing is choose the material property for steel. Again, here you do not have option to select main steel and stirrup steel separately. Okay, only one property you can choose here. Then tie bar diameter you can choose, let's say 10. Corner bar you can choose 25. We have already used 25. Then corner bar 2, corner bar 3, 4. Okay, and edge bar 1. I don't know which is edge bar 1, edge bar 2. Let us check. So in one side you have 1 bar, other side you have 3 bar. Maybe that is correct interpretation. Whatever you have done itself. Yeah. Okay. And again, if you click on this, now this I think this one. Yeah, here you can choose clear cover. Earlier in SAP we have used the effective cover, but here it is specified as clear cover. So whatever clear cover you want, you can enter this value. So now again your section is ready and you can just click on this option and it will give you the moving curvature. Now let us compare the values. You have two software and in this software we didn't assign any meta model parameters. Okay, but the value what you are getting, it is around 640. I think this was the same value what we have obtained from SAP. Let us check once again. At 0 degree axial force, 0 axial force, it is around 640. Okay. I don't know how software is calculating because as per our understanding, the values will change depending on how much stirrups you are providing, how much spacing you are providing, and diameter, and how many legs. Okay, all those things will affect your capacity. But both the software will give you the same result. I don't have understanding how it is giving. Okay, maybe it is conservative side, only the minimum level is considered. Something is there. Okay. Minus 1000. And here also you can see when you are increasing the axial force, your capacity is increasing, the height is reducing, and initial stiffness is increasing. Okay. Is it clear? Now you can practice for 10 minutes in your system. After that, we'll move to next part. You take any random size with random reinforcement according to you and calculate this thermal capacity.
मतलब नेगेटिव ये है। हाँ जी, इसका ये है ना, टेंशन को पॉजिटिव ले रहा है हमारा जो
पॉजिटिव देखिए देखो आप कैसे सेंड
अच्छा
डाउन आएगा सर।
हाँ, टेंशन होगा ना, टेंशन होगा कुछ क्या हुए इतना तो होगा ही नहीं। बंद हो गया भाई अपने आप, वजह लेट है वही अपने आप बंद हो गया। अब खुलेगा नहीं लग रहा मेरे को, यही तो बनाना है। हाँ टैप तो है वो, कुछ भी लगे
2x2
हाँ
2x2
फर्क नहीं पड़ गया, कुछ भी लगे रेट से कहाँ फर्क पड़ेगा उसमें, तो क्रॉस सेक्शन ले जाना भी अंदर देखो।